Hello to everyone. I am Professor Raja, working as Assistant Professor EC Department, SNS College of Technology, Coimbatore. In this YouTube video, I am going to discuss the detailed explanation of how a components of embedded system is working. So, based on my previous video, you may have some idea about what is in by embedded system and what are the applications of embedded system and what are the input-output components used in embedded system. Now, we are going to see the detailed explanation of how the individual blocks in embedded system is working. The building process, the first step is selecting a process or a processor. The processor is selected from the following consideration: instruction set, maximum bits, clock frequency in megahertz or gigahertz. Processor, it is the ability to solve a complex algorithms used in meeting the deadline for the processing. The build process for embedded software consists of the following steps. Project file consists of source file and library file. Compilation of the project files, linking all object files and locating onto a single relocatable object file, converting the object file in a form called hex file to binary image. These are the various building process, that is a compiler, a assembler, a linker and a loader is available to check how this embedded system processor are working. Design process in embedded system, that is the concept used in design process are abstraction, hardware and software architecture, extra functional properties, system related family of designs, modular design, mapping, user interfaces design and refinements. These are the software design oriented architecture. And a design process in embedded system like a design metrics. These are the design metrics considered while we are going to use any embedded processor. The first one is the power dissipation, performance, process deadlines, user interfaces, size, engineering cost, manufacturing cost, flexibility, prototype development time, time to market, system and user safety, and the last one is the maintenance. These are the various abstraction of steps in design process. First, we are getting the requirements from customer or the user domain. Then we have to provide a proper specification. Then based on the customer requirement, we have to design the architecture, that is either a hardware architecture, also a software architecture. Then we have to decide what are all the input output components that we are going to use. Finally, a system integration, that is the combination of hardware and software are combined together for some specific task. So after this system integration, we have to check whether the customer requirements is satisfied based on their needs. So structural units in embedded processor, the internal buses, it internally connects all the structural units inside the processor. Its width can be 16-bit, 32-bit or 64-bit. Next one, address bus. It is the external bus that carries the address from a memory address location to the memory as well as the input-output devices and other units of the system. Then third one, data bus. It is an external bus that carries data from or to the address. Control bus, it is an external bus to carry control signal between the processor and the memory devices. Bus interface unit, it is the interface unit between the processor's internal units with the external buses. MAR, memory address register, it holds the address of the byte or word to be fetched from external memories. MDR, it holds the byte or word fetched from to external memory or input output address. Program counter, the program counter holds memory address of the next instruction that would be executed. Stack pointer, it is a pointer for address which correspond to stack top in the memory. Instruction register, it takes sequentially the instruction code to the execution unit of the processor. Instruction decoder, it decodes the instruction opcode received at the IR, that is instruction register, passed into the processor CPU. Instruction queue, It is the queue of instructions so that the IR doesn't have to wait for the next instruction after one has been carried out. Arithmetic and logic unit. It is a unit to execute arithmetic and logical instruction according to the current instruction present in the instruction register. Next one, floating point processing unit. A unit separate from ALU for floating point processing, which is essentially in processing mathematical function fast in a microprocessor or a DSP. Floating point register set, that is FPRS, a register set dedicated for storing floating point number in a standard format and used by FPPU for its data and stack. Control unit. It controls all the bus activities and unit functions needed for processing. Memory management unit. It manages the memory such that instruction and data are readily available for processing. Application register set. It is a set of on-chip register used during processing the instruction of the application program of the user. Instruction cache. It sequentially stores like an instruction queue the instruction in FIFO order. Data cache. It stores the prefetched data from the external memory. The data cache generally holds both the key and the value together at the location. Prefetch control unit. It is the unit that controls the prefetching of data into the on cache and the D cache in advance from the memory units. The instruction and data are delivered when needed to the processor execution unit. Register window. A register window consists of a subset of registers which each subset storing static variables and status words of a task or a program thread. Advanced processing unit. These are units that's used for multi-stage pipeline processing, multi-line superscalar processing to obtain processing speed higher than one instruction per clock cycle. Atomic operation units. It lets a user instruction when broken into number of processor instruction called atomic operation finish before an interrupt of a process occurs. So in this YouTube video we are seeing a detailed version of how inside a embedded system components are working. So next YouTube video I am going to discuss the internal architecture of 8051. Thank you.